In this video, I'll give you a quick overview of what a color space is and what color profiles are in digital photography. We'll be using CameraBag to show what's going on, but the same principles apply to most photo editors. Let's get to it. The horseshoe shape in this image represents all the colors visible to the human eye. In a high-level sense, a color space represents a subset of the colors the human eye can see. Most computer and phone screens can't actually display all the colors your eye can see in the real world, but they can display a pretty decent subset of them and will show a color as close as possible to the real world color when they can't show the actual real world color. These two triangles represent two common color spaces used in digital photography, the Adobe RGB color space and the sRGB color space, which many computer monitors are able to show fairly accurately. As you can see, these are each a smaller subset of all the colors the eye can see. When a JPEG image file has an sRGB color space embedded in its metadata, it essentially tells the device displaying it, when I say a pixel is the brightest greenest green, I mean the brightest greenest green in the sRGB color space, which is a definable real-world green. The brightest greenest green in the Adobe RGB color space is a different real-world green than that in the sRGB color space. Let's get into a bit more detail of how this works and why this is needed in digital photography. Most colors the human eye can see can be recreated with the right combination of red, green, and blue light. Each pixel in your computer display, if you zoomed in really close, has a tiny little red, green, and blue light component inside it. Different levels of brightness of red, green, and blue in each pixel make up all the colors you see on your computer screen. White pixels, for example, have each red, green, and blue component set to 100% brightness. Bright red pixels, like the ones in this box, have the red component turned up to 100% and the blue and green components turned all the way off. Pixels that look yellow on your screen have the red and green components turned up and the blue component turned down or off. A sky blue pixel in a photo might have the red components turned on around 40%, the green at 70%, and the blue at 100%. When an image is stored in a file like a JPEG, each of its millions of pixels, red, green, and blue components' brightnesses are stored. However, what real-world color does it mean if the file says a pixel should be, say, 100% green with no red or blue? If you lined up 10 different computer displays made by 10 different manufacturers next to each other, and had them all show pixels with 100% green and 0% red and blue, they would all look green, but the green would look a little different from one display to the next because of differences in manufacturing processes and materials and other reasons. Each different monitor has its own color space of real-world colors it can display. This is where color profiles come in. As mentioned earlier, when an image has an sRGB color profile included in its metadata, it essentially tells the computer, when I say show a pixel with 100% green and no red or blue, I don't mean set your green pixel components as bright as possible and your red and blue components totally off. Instead, I mean set your pixel components to whatever values show what most looks like the real world brightest greenest green within the sRGB color space. Modern computers and monitors have detailed mathematical formulas tuned to each different monitor and its color characteristics that tell them how to convert the pixel values in an image file into colors as close as possible to the intended real-world color in a given color space. For example, 100% green in the sRGB color space may be best represented on my particular monitor by setting its pixels green components on at 93% strength, its red components at 3%, and its blue components at 5%. The formula that converts the color space value into the actual display values for a specific monitor to use is called a color profile. Having color profiles embedded in an image allows different monitors to display the same image with roughly the same real-world colors, despite the different color characteristics of each monitor. This can make a big difference in digital photography, ensuring that the colors in a photo will look natural and lifelike no matter which monitor they're displayed on. Without color spaces and color profiles, the skin tones in a portrait might look natural on one monitor, but greenish or oversaturated on a different monitor. CameraBag has an adjustment tile in its utilities section that lets us see how this plays out in digital photo editing. By default, CameraBag works in the color space that is embedded in each file's metadata, usually sRGB. However, if I drop in this color space adjustment, I can override that and see what it looks like if the same pixel color values are interpreted as being in one of several different color spaces. When you have a color space tile included in your CameraBag adjustments, you'll be working in the selected color space, and you'll see colors in that color space as accurately as your monitor allows. The color space data will be embedded in the metadata of your image file when you save it out. Because this video file that you're watching has a specific color space itself that can't display all possible colors, and because you're potentially viewing this on a monitor or a phone that has its own limited color space, there's no way to accurately show in a video how the colors on my screen change when I change color spaces, but you can likely see some slight differences as I switch between them. If your monitor supports it well, working in the Adobe RGB color space gives you a wider color range to work with than sRGB, and thus can result in more accurate, natural colors. However, the sRGB color space is more widely supported across different displays. Thus, working in sRGB is more likely to produce consistent results across more devices. This is why most of the images you'll run across on the web use the sRGB color space. The Rec. 709 color space is widely used for videos and will be the most compatible color space for you to work in if you're processing videos in CameraBag. I hope you found this video useful. Download the CameraBag trial and try viewing a photo or video in different color spaces on your own monitor to see the real-world differences in person.